Hi all, today I'm gonna talk about stoichiometry, and we basically are going to continue the concept of unit conversion method. If you forgot about it, please go back to the video and review it before you come back, before start this concept. In the stoichiometry, we need a chemical equation. We need a chemical equation which is balanced. This chemical equation, if you closely look at it, is balanced chemical equation. And then we need, the same as we were doing with the unit conversion method, we need to start with a given number and but in the stoichiometry, we need to relate compounds in the chemical reaction to each other. So the definition of it is the quantitative relationship between reactants and products in a balanced chemical reaction. So we need to connect these compounds to each other using coefficients. We know that the coefficients which are in front of each compound are the result of a balanced chemical reaction. Okay, let's consider this following reaction. Is it balanced, guys? No, right? So I'm gonna balance it. And then we want to see what's the relationship between, H2 to N2 here. How we can relate the H2 to N2. You might ask, okay, how I can do that? So I know that hydrogen has 2 subscript here, N has 2 subscript here, but no, we don't look at the compound here to relate them. We use the coefficients which are in front of the compounds to relate them to each other. So whenever we relate the compounds in a chemical reaction, we use coefficient to relate them. So the relationship between H2 to N2 here, so the coefficient for H2 here is 3 and for N2 is 1, so is 3 to 1 here. We always want to, when we want to use these ratios in the conversion as a conversion factor, and when we want to use them in the unit conversion method, we need to use them as a mole. So we put unit of mole next to them. We just say, okay, I have, what does it mean? It means that I have 3 times mole H2 compared to 1 mole of N2, right? That's what it says. It says I have 3 times mole H2 compared to 1 time of N2. So it just shows the ratio. For example, if your friend has 9 bread and you have 3 bread, you tell that, okay, you have 3 times more bread than me. So it's just relationship between them. You just say that, okay, I have 3 times more H2 compared to N2, in this equation, and it always stays the same. Ratios always remain constant. Why? Because the balance equation is always the same, right? We always, when we balance it, we always have 3 H2 in front of the hydrogen, 1 N2 and 2 NH3, right? We always have these the same. They never change in the balanced chemical equation. So to make it easier to use it in the chemical equation, we put the mole next to them to be able to relate it in the unit conversion method to each other. Okay, so what about, so now do it yourself, guys. What about ratio between N2 to NH3 here? So we should basically use the coefficients, right? So the N2 to NH3 is 1 to 2, 1 mole of N2 to 2 mole of NH3. Okay, let's do more questions here. So we have the following equation. Make sure always check if you have a balanced chemical equation. So always the first thing is make sure you have a balanced chemical equation. So we have here 8 carbon in the left side, 8 carbon in the right side, 20 hydrogen in the left side, 20 hydrogen in the right side, 26 oxygen in the left side, and 26 oxygen in the right side. Then, so let's do the following ratios. So what do you think is the ratio between the C4H10 and O2? We have 2, which is the coefficient of this compound C4H10, to 13, which is the coefficient. So we basically relate them to each other using their coefficients, which is the outcome of balanced chemical equation. What about the second, guys? Is O2, which is 13, compared to carbon dioxide, which is 8. Here I just did not add the mole here because I just want you to see the relationship between them. For the third one is 2 to 8, 2 to 8, right? Because of the coefficients. Fourth one is 2 to 10, is C4H10 to 10H2O. 2C4H10 to 10H2O. And the last one, CO2 to O2. So what do you think? Is 8 to 13. So you should just see what is the coefficient. So it does not matter. You want to find the ratio between reactants to products or products to reactants, or even reactants to each other. Okay, or products to each other. We can always relate them using their coefficients. Okay, let's see how it comes in the exam. Okay, so we have the chemical equation that I used in the last slides, and then let's see how we can do the question. Basically, we have the above, so always they give you a chemical equation and you should make sure it's balanced. Then they ask you a question. If we have 1.5 moles of H2, how many moles of NH3 we can make? So you might ask, okay, how it's possible? They ask for H2. Why they ask for NH3 here? You might ask, okay, did the instructor make a mistake? No, it's not a mistake. They want you to use a stoichiometry here. It's a magic, right? Magic, chemistry is magic. They give you another compound, they want you another compound, right? So this is why we call chemistry probably magic, right? Okay, so the first step here is to find ratios between the compounds that is asking for. You don't necessarily need to relate all of the compounds now. Just look for what is asked, what is given, and what is asking for. Here, the 1.5 mole of H2 is given. So is given, this one is 1.5 mole of H2 and is asking for mole of NH3. We already know that I should use the coefficients of the compounds H2 and NH3 to relate them to each other. So I know that I need 3 times H2 equal to 2 times NH3, right? So always this relationship stays the same. So how we use it? We start the same as always in unit conversion method. We always start with what? Start with a given number. Then we use these coefficients relationship that we got. So I put 2 mole NH3 over 3 mole NH2. Why, guys? Why I should do this in this way? Yes, because the mole of H2 should be in the denominator because it should cancel out. Do you remember? The denominator should cancel out with the previous nominator, right? So they should cancel out. The units should cancel out. So always make sure follow the same unit should be this in the denominator with the previous nominator. Okay, so then I related them to, I related H2 to NH3. So my final is now NH3, is the mole of NH3, right? Here I have the mole of NH3. I do the calculations. The answer is 1 mole NH3 basically. So with 1.5 mole of H2, I can make 1 mole of NH3. So let's do one more question. Consider above equation. If we have 5.2 mole of N2, how many moles of H2 can we make? Okay, so I want you to pause here and see if you can do it yourself. First, make sure that you have a balanced chemical reaction. Okay, so always in a stoichiometry, there is a chemical equation. Okay, always there is a chemical equation. If they don't give you chemical equation, is because they give you enough information to write it yourself. You should write down the chemical equation yourself from whatever they give you. So they give you the reactants, either they ask for the product to predict the product, or they just give you the name of reactants and products and ask you to write the formula and balance them. So these questions is hard, but this type of question that they don't give you, they don't provide the chemical equation, is hard. And to be honest, it's not going to be a lot in the exam, but try to be ready for that type of questions. So we have this equation, we make sure it's balanced. We have a given number here. So we have a 5.2 mole of N2 here, and they ask for what? They ask for mole of H2. So we start with the finding ratio, with the using coefficient, 3 mole of H2 with 1 mole of H2, which here 1, it means when we don't have a coefficient, it means it's 1. Then we start with a given number, like unit conversion method, and then we should use this ratio that we found as a conversion factor. Make sure here this mole of N2 should be in the denominator to be cancelled out with the previous nominator. And the final answer should be in 2 sig fig. Make sure, guys, the same as unit conversion method, follow the sig fig rule. So with 5.2 mole of N2, I can make 1.6 mole of times 10 to the power of 1 mole of H2. Okay, so in the previous slides, I talked about just mole to mole conversion. They give you the mole as a given number and they ask for another mole in the question. So that's what we basically had. They gave you a mole, you should use the ratio from balanced chemical equation to find the mole of another compound. But what about if they give me a mass of a compound? What should I do? What I told you before, guys, when they give you a gram of something, always convert to mole, okay? Convert to mole first. So you're gonna convert to mole first, and then you're gonna find the relationship between the two compounds using coefficient. Never ever, guys, try to find the relationship between compounds with the mass of them. Never ever. Use the mass. Always first convert to mole, then use the ratios. That's what the students usually make mistake. They just use the mass as a given number and just use the coefficients to convert to another compound, but they miss a step. They should first convert the mass of a compound to the mole of a compound, and then they should find the relationship. In a harder question, so the hardest I can give you, I give you the mass, so then, and I ask for the mass. So they give you a mass, so you should first convert to the mole, use the balanced equation, and use the coefficients to convert to another compound, and then you should convert the final compound to the mass or to the gram. And this is asked, guys, in the question. Okay, they give you a gram and they ask for the gram of another compound. So the question specifies for that. Okay, let's do another question in this format. We have this question, and I mean, basically this equation, which is balanced. I make sure it's balanced. So considering above equation, if I have 2.2 gram of H2, how many moles of N2 can I make? So I first start with a given number, right? What should I do first? Convert to mole of H2. I use the periodic table to add up two hydrogen mass, atomic mass of two hydrogen is 2 gram of H2. So these atomic mass, guys, it depends on the periodic table you use. So please pay attention to what periodic table is given in the exam, and you can go based on that periodic table. So then we use the coefficient here to use the 3 mole of H2 to 1 mole of N2. Why I used here mole in the bottom, I mean H2 in the bottom, because it should cancel out with the previous mole of H2, and this is what is asking for in the question. Make sure, guys, always double check. So we make sure follow the stick figure rule for that. It's better always, guys, to your final answer to be in the scientific notation. Okay, so let's do another one. If we have 2.4 gram of NH3, how many grams of H2 can we make? So they gave us a gram of NH3. We use the atomic mass of nitrogen and hydrogen to add up the masses, and we convert to mole of NH3. Based on the chemical equation, 2 mole of NH3 reacts with 1 mole of N2. So you can see here, guys, why we use a mole for this step. Because we want to relate it to the mole of the previous one, right? Because we convert to mole in the previous step. To be able to use it, we should put the mole here. So the mole cancel out, and then is asked for how many gram of H2 here. So I should go more a step, make sure that here I made a mistake. So this is basically the usual mistake that that's the usual mistake that I see the students make. Make sure, don't forget to double check that we have H2 here. So with the 3 mole of NH3, right, is asking for NH3 to H2. So here, so for sure, my answer will be different. Is 0.047 gram of hydrogen. Point 42. Okay, guys, for the next question, if we have 2.4 gram of NH3, how many gram of H2 can we make? So we always start with a given number. We convert to mole first. Then we use the coefficient, which is 2 mole of NH3 to 3 mole of H2. And then we convert to the gram of H2 because it's asking for the gram of H2. Now you can see, guys, why we use the mole here. Because the previous is mole. The previous nominator is mole, so I should put mole here. So that's why we use the unit of the here the coefficients when we put them inside the calculations, we put the mole as a unit of them. Make sure that the denominator should be the same as previous nominator. Always double check and make sure the final answer is 2 sig fig with following 2 sig fig in the given number. Okay, guys, the important thing I wanted to tell you is that make sure whenever you convert gram to mole, always put 1 mole here. So because in each 17 gram of ammonia is only 1 mole, right? We just do the regular conversion that we were doing before. We just convert gram to mole, right? And whenever here also we want to convert mole to gram, we just use how much is the atomic mass of, and here, for example, molar mass of H2 here is going to be 2 gram of H2. So 1 mole of H2 is going to be 2 gram of H2. So the only place that we use coefficients from the chemical equation is only whenever we want to convert from one compound to another compound. Here, for example, I want to convert ammonia to hydrogen. I use the coefficient, right? So 2 mole of ammonia to 3 mole of hydrogen gas, and I use the coefficient. Whenever I want to convert gram to mole or mole to gram, I always use 1 mole here, guys. Always. That's what I see usually students make mistake. They use here, they put the coefficients of the compound here. But you should not, again, you should not put the coefficients when you want to convert gram to mole or mole to gram. Always put 1 when you want to convert 1 mole, whenever you want to convert mole to gram or gram to mole.